if there are reactions where it's not easy to figure out where there is a transfer of electron from and which element is losing or gaining electrons, we need to calculate oxidation state of the element. This oxidation state allows the determination of electron flow. Now, even though they tend to look like charges, because sometimes we write it as oxidation state of oxygen is -2 and oxidation state of chlorine in some systems is -1. Even though they look like charges, they're not exactly charges. They're not charges according to what we say are charges on a periodic table, but these are imaginary numbers assigned based on some rules. Now, ion charges on the other hand, or charges on the other hand, are measurable numbers. So the difference between charge and oxidation state is that charge is a real measurable number and oxidation state is an imaginary number assigned based on a set of rules. Now let's see what those rules are. Free elements have an oxidation state of 0. What do we mean by that? In a reaction, if you see sodium or chlorine or oxygen, so these are free elements, right? They're not compounds, but they are free elements, and these have an oxidation state of 0. Monoatomic ions have an oxidation state equal to their charge. So if you see an ion, say potassium +1, this is an ion. So the oxidation state in this case is the same as the charge. The sum of oxidation states of all the atoms in a compound is 0. So if you see a compound, sodium chloride, oxidation state of sodium is +1, oxidation state of chlorine is -1, and the sum of this is 0. So sum of the oxidation states of all the atoms in a compound is 0. The sum of oxidation states of all the atoms in a polyatomic ion is equal to the charge in the polyatomic ion. If you see carbonate ion, for example, right? Oxidation state of carbon plus oxidation state of oxygen, and there are 3 oxygens, this is oxygen, not 0. Okay, oxidation state of carbon plus 3 times oxidation state of oxygen is equal to -2. So sum of all oxidation states of atoms in a polyatomic ion is equal to the charge on the ion. And group 1 metals have an oxidation state of +1 in all their compounds. Group 2 have an oxidation state of +2 in all their compounds. In their compounds, non-metals have oxidation state according to the table below. Fluorine always has a -1. Hydrogen always a +1. Oxygen always a -2. Group 7A, -1. Group 6A, -2. Group 5A, -3. There is a small exception to this. In peroxides like sodium peroxide or hydrogen peroxide, oxygen has an oxidation state of -1. So this is an exception. So in peroxides, everywhere it is -2, but in peroxides, oxygen has a charge of -1. So these are some of the rules for assigning oxidation states, and you have to memorize these rules. Now, once you calculate the oxidation number of all the elements on the reactant side and the product side, now you compare the oxidation states on both the sides. So carbon has an oxidation state of 0, and we will work on problems on how to calculate oxidation states according to rules. and sulfur has an oxidation state of 0 on the reactant side. On the product side, carbon has an oxidation state of +4. Like I said, I will tell you how to calculate that when we work on problems. And sulfur has an oxidation state of -2. So now you compare carbon on the reactant side is 0 and on the product side it is +4. Oxidation number of carbon increased. This signifies that carbon is oxidized. And this, so carbon is oxidized. Look at the reaction. Which substance did carbon react with? Carbon reacted with sulfur. So sulfur is oxidizing agent because sulfur is responsible for carbon to oxidize. In the same manner, sulfur has reduced. Sulfur went from 0 to -2. So oxidation number decreased, and a decrease in oxidation state signifies reduction. So sulfur is reduced. So carbon is reducing agent. So pause, think about this and rewind the video and go back and work on how to remember the oxidation state rules. And remember, if an element increased oxidation state, that means that element got oxidized. If an element's oxidation state decreased, then that element got reduced. Okay, and you need to be able to identify which element got reduced, which element got oxidized, and what is the oxidizing and what is the reducing agent.